Okay, we'll go to the whiteboard in this one. It's number 5. It says, what's the smallest integer n? It's a positive integer. That means n's got to be greater than 0. So that this equation over here is going to produce an integer. I shouldn't say equation, expression produces an integer. Now looking at it, something I wanted to point out, and I did set some false starts in this one over here, but I know the n, which is an integer by the way, has to be greater than 0. And again, I know n is an integer. It's got to be greater than 0, positive number. Now looking at it over here, I want to point out that one of the things you really need to look at is this guy over here, because this would be defined for all positive integer n, all right? This one over here, I got to be concerned about it. And what I know about this over here is that the n, right, I can't exceed a certain number over here. And the thing is, I can't do this over here. I can't let this happen. I should say, I can let that happen, but what I mean, I can't let, let me write this over here, 100. I did it again. Something to do with the root of n, right? So I'm going to say over here, I can't let this occur, all right? Because if this is bigger than 100, I'd have a negative number over here, all right? So I'm going to say the max I can get over here is going to be this number over here, all right? Now someone's going to say, well, why don't you just simply start looking at numbers and see what works? And that would be called brute force. And I'll be honest with you, when I first saw the problem, I said, maybe it's a brute force problem. I just plug numbers in over here. But one of the failures I had was I was looking at n's, and I wanted n's to be perfect squares. But, that's kind of an assumption that's not true, by the way. And that was a bad approach, by the way. So I had to stop it and then rethink it. And that's why I'm going to go to the whiteboard and rethink the problem, by the way. And I'll write this one down for you. And I'm going to tell you that I'm thinking of some number. And I'll write this one over here. I know m is going to be an integer. And I want to point out my integer I'm looking at over here. And I'll tell you what m is equal to in a moment, by the way. But it's going to be a positive integer. I know that much. Let me write this over here. I'm going to say m is equal to, and it's equal to that expression. Oh, by the way, n is also a positive integer. And I got this over here. Okay, I got that. Okay, so what I'm going to do over here is look at this over here. And I'm looking at it, I'm saying m's a positive integer. Looking at this as the sum of two things, but I still don't know what n is. And what I'm going to do is, what you probably do at a lower level, of course, is just square both sides. And I'll write this one down. So you get m squared. This is a tough part, by the way. When you square this guy, not that bad. Square that guy, it's not bad. Let me write that down. You get 100 plus root n plus 100 minus root n. Then you're going to get plus 2 times this guy times this guy over here. Again, I want to remind you the n is greater than 0, but less than this number over here. All right? Wow, what happens here? This disappears, and you're left off with m squared is equal to 200 plus 2. And what I want to do is I want to take these two root problems and bring them together. And what I notice about their conjugates, like 100 plus root n, 100 minus root n, they're just conjugates. So I think I can write that down in a simpler way. And that's going to be what? It's going to be 100 squared minus root n squared, which is just n. All right? So we got some troubles over here. And someone says, what are your troubles about this over here? I'm still in a situation where I'm looking at this thing and saying, what do I know about this? I'm looking at the size that m could be. And I want to put this over here, that m squared. All right? And I'm looking at it, and I'm wondering what the smallest it could be. And that's sort of like looking at, I know it's going to be 200 at least, right? So look at this over here, and I'm going to say, this could get really close to 0. So I'm going to say, I guess 200 would be the lowest thing, but it's going to be above that. And what do I know? I'm adding something onto it. All right? So I'm going to say it's above 200. And then the next question is, what's the most it could be? All right? Well, I know n can't be 0, but I'm saying if it were 0, I would get 100 squared. But you get close to 0, right? I mean, you close to, you get 1. You get close to 0, by the way. It's going to be 200 plus, well, it would be 200, which is 400. All right? That's not a bad place to start with this. All right? That I know the m squared is between 200 and 400. So then I got to start thinking about, m's a positive integer, by the way. And I'm wondering what this thing is over here now. All right? So I'm going to say, well, 400 is pretty easy, right? I mean, it was just going to be 220, right? That's not so bad. And then I'm looking at the 200, and I'm wondering, that's not a perfect square, by the way. But I'm thinking, if I did 15 squared, that would be 225. So I'm going to say that this thing here has got to be greater than 14. Now, 14 squared, that's 196, right? Yeah, so the m is definitely greater than 14 to 20. Now, that's something nice because I don't have many integers over there. And what integers do I have? Well, if you look at the integers, you'd have 14. Oh, I couldn't do 14, so it's going to be 15, 16, 17, 18, and 19. These are the integers I got. However, I'm looking at this thing over here, and what I kind of notice about this over here is this is going to be an even number. So I want to point out some of these numbers that can be discounted, and I'll tell you why. If I took a number, and I'll just put down 2n plus 1, which is odd, and you were to square that, what would you get? 4n squared plus, let's see, 2n, 4n plus 1, which would make it odd, all right? So I know m can't be odd. So I throw this out. What other number do I throw out? I throw out 17, and I throw out 19. Now I just got 2 numbers left. And what are the 2 numbers I have left? I have m equals 16, and m equals 18. They're 2 separate numbers over there. So what I want to do is I want to kind of go through that and see if I can figure out n now. And I don't know. Let's take a look at that. So 16 squared is 256. By the way, I'm using this equation now. Whoops, sorry about that. I'm using the fact that m squared is equal to 200 plus 2, and this will be 100 squared minus n. By the way, n's got to be an integer, so I'm a little concerned about this now, but m squared 256 equals 200 plus 2, 100 squared minus n. Kind of nasty, isn't it? 56, take 200 from both sides, 2, the root, 100 squared minus n. Divide by 2, you get 28 equals a square root 100 squared minus n. Getting closer, aren't I? And I'm going to, maybe not do too much arithmetic now. I'm going to put 28 squared down equals 100 squared minus n. I'm going to say n is 100 squared minus 28 squared. I've got to do some work here, don't I? N equals, difference of perfect squares, by the way. I'm trying to reduce the amount of arithmetic I'm doing, by the way. That's all I'm doing. And 100 minus 28. N is equal to, clearly an integer, by the way. It's going to be 128. And that's going to be 72. All right, I got to do the arithmetic, by the way. And I hate to do it, but I have to do it. Because I can't do that in my head. There's some things I can't do in my head. 128 times 72. 2 times 8 is 16. This is most likely where I'd make a mistake in the problem, by the way. 2 times 8 is 16. 2 times 2 is 4. 4 is 5. You get 2. Well, that makes sense, right? I could have put that without doing an arithmetic over there. Let's see, 0. I might erase her out. Let's see, 7 times 8. That's 56. 14, 19. 7, 8, 6. Let's see, 11, 12, 9, 2, 1, 6. Okay, so I got one answer. Let's do the other one now. And oh boy, it's a lot of work, wasn't it? No, let's do the m. 18 squared. Again, I already did the 16. I'll do that later, by the way. 200 plus 2, the square root, 100 squared minus n. I got to do 18 squared, right? Let me do that on the side. So 18 times 18. Let's see, 10 times 18 is 180. That's not bad. 8 times 10 is 80, and 8 times 8 is 64. You get 4. 8 and 8 is 16. 16 and 2 is 22. And you get 324. Whoops, that's not correct. 324 equals 200 plus 2, 100 squared minus n. I'm still trying to figure out n, by the way. That's going to be 124 equals 2. Let's see, square root 100 squared minus n. Divide by 2, that's going to be 62 now. And then you get the square root 100 squared minus n. I'm going to square both sides, 62 squared, 100 squared minus n. So n will equal 100 squared minus 62 squared. I'm going to do the same thing I did before. I'm trying to reduce the amount of arithmetic I'm doing. 100 minus 62 and 100 plus 62. N equals, that's going to be 38, and this is going to be 162. Wow, got more arithmetic to do, don't I? Let's see if we can do that. So 162 times 38. Let's see, 8 times 2 is 16. 8 times 6 is 48, 49. 8, 12, 0. Get my eraser out. Let's see. I just forgot where I was. Oh, 3 times 2 is 6. 3 times 6 is 18. And that's going to be 4. 6, 5. It's 15, by the way. 11. And 6. So n would be equal to 6156. You know, after all that work, I can't remember what the question was. I'll take a look at it. It says, what's the smallest and largest n? Well, the smallest n is what? 6156. The largest n is 9216. I'm going to keep reading the question, make sure I did that right. What's the smallest and largest? And we did find that, all right? And we found the smallest integer was 6156, and the largest one was 9216. I found this question to be difficult. And I'll tell you the number one reason why. I had some false starts on it. And the false starts were, I was thinking it was going to be really easy to do a hunt and peck, not considering if I had a hunt and peck for numbers over here, I'll be honest with you, I'd be here all day long. But my worst thing about it was I thought that these numbers here would be nice numbers, and they're not nice numbers, all right? But anyway, we just finished the problem out, and we're completed. Thank you.